Now I will tell you about the key points of the Ohm's law. These are important from all the competitive exams and also for the students who are preparing for board exams. This law gives a relationship between voltage and current in a conductor. So what we have is V upon I. This is equal to a constant. The ratio of V to I is constant called resistance of conductor. The graph V versus I is a straight line passing through the origin whose slope or gradient gives the value of resistance. It is equivalent to straight line y equal to mx. So what we have? That this is like this. This is now your y-axis. This is now x-axis. This is origin. This is now your v. This is now I. Then it will be a straight line. So this is the slope theta. This is supposed to be. So slope or gradient m equal to tan theta. Therefore, resistance R equal to tan theta. R equal to tan theta. Now from here you can see that we have taken the voltage on the y-axis and current on the x-axis. Then whatever is the slope with the x-axis, that is the gradient, that is denoted by m. This m is the gradient or is so the slope, and this is equal to tan theta. This we can see from this right angle triangle. This is now your value of v. This is now value of I. So v upon I. This is equal to r. So what we have that when this situation is then larger the gradient or slope, larger is the resistance. It shows that larger is the gradient, more will be resistance. So what we have, suppose we are having this is now x-axis, this is 0, here we take this I, this is now y-axis, here we take now suppose V, and let we are having these two straight lines. Let this is the represents this R1, this represents R2, this angle is suppose theta 1 and this angle is suppose theta 2. So the theta 2 is more than theta 1. So this definitely is R2 is more than R1. Clearly. R1 is less than R2 or R2 greater than R1. In this way, when we are having this kind of the graph, if V is on x-axis and I on y-axis, then inverse of gradient is equal to the resistance, So what we have, suppose we are having to this one, this we take now x-axis, this we take now y-axis, here we take I, this is 0 and this we take now V in this way. Then what will be? This is no slope. Theta. So what we have? This is suppose the line OP. Then this 1 upon 10 theta. This is equal to what I have said? V on x-axis, I on y-axis, then inverse of gradient. Inverse of gradient means 1 upon 10 theta. This is equal to the resistance. So this is equal to cot theta. This is equal to 1. Now when this is so, then larger the value of theta, less is the resistance. It means that larger is the value of theta, less will be the resistance. So what we have, suppose we are having this is now suppose x-axis, this is now y-axis 0, and here we take this V, here this we take I, and suppose we are having these two lines. This is now resistance R1, this resistance is R2. This is suppose angle theta 1 and this angle is theta theta. What means that? Larger the value of theta. Here is, this is just opposite to this one. Here is what? That larger the value of gradient, more is the resistance. Here is larger the value of theta, less will be the resistance. So R2 is less than R1, which means that R1 is greater than R2. Clearly, R1 greater than R2, or R2 less than R1. This is what we mean. This is. But this should be remembered that on which axis we have taken which physical quantity. When P is taken on pi axis and I is taken on x axis, then larger the value of theta, more is the value of this resistance. And when we have taken I on the y axis and V on x axis, then larger the value of theta, less is the resistance. So this you have to keep in mind that what is given on the x axis and what is given on y axis. This law is valid for metals and alloys or compounds. Alloys are the compounds. So metals, in metals what we have? Let we have this your aluminum, copper, iron, nickel, cobalt, silver, gold, etc. And this alloys or compounds, we have this, suppose now this the nitro constantum, and that we have the brass, or we have bronze, etc. These are the alloys or compounds, because in this the metals are mixed in a definite ratio, so they are called the compounds. So for this law holds very good. Now we have seen that graph versus V and I is a straight line. This is up to a specific temperature, but when temperature is very high or very low, then this Ohm's law is not valid. Ohm's law is not valid for at higher or very low temperature. at very high or very low temperature, the VI curve is not a straight line, is not a straight line. Passing through oil. Passing through oil. So it means that Ohm's law holds up to a certain specific temperature. Ohm's law holds up to a specific temperature. Truly speaking, Ohm's law is no more a law, but it defines the resistance called ohmic resistance. तो ओम्स लॉ कोई लॉ नहीं है, बल्कि ये तो रेजिस्टेंस को डिफाइन करता है। तो डिफाइन क्या करता है? द रेशियो ऑफ V to I is called resistance. The ratio of V to I is equal to resistance. It means what? That this V upon I, this is equal to R. This is what? The Ohm's law. So this ratio defining the value of the resistance of the conductor. Ohm's law is equivalent to Hooke's law. Hooke's law, which states that stress is proportional to strain under elastic limits. Under elastic limits. It means that this stress is proportional to strain, or this stress upon strain. This is equal to a constant called coefficient of elasticity. So what we have? This is the stress, this is the strain, this is x-axis, this is no y-axis, this is no origin, then it is like this. This is also a straight line, which is also equivalent to the straight line y equal to x. So slope of this line represents this coefficient of elasticity. Now this is now slope. So slope of straight line represents the value of coefficient of elasticity. So what we have is tan theta. We are adding to this one. This is equal to coefficient of elasticity equal to tan theta. This is no what. So this is Ohm's law is equivalent to the Hooke's law. It's about this law you will study when the chapter of elasticity will be taught to you, and this is just like the stress proportional to strain. So stress upon strain equal to constant called the coefficient of elasticity. So this is just like a line like this one. This is suppose we take now V, this we take the I, then this is no straight line. So slope represents the value of resistance in that in the case of Ohm's law. But here the slope represents the coefficient of elasticity. So this is what the a comparison of the Ohm's law with the Hooke's law. Ohm's law is not followed by superconductors. Superconductors are what? The current in superconductors persists for very long time, even when in absence of voltage source. So what we have, this V equal to 0, then R equal to V upon I, so this is now 0 upon I, so this R equal to 0. It means that the superconductors have zero resistance. So if we draw a curve for this, this is now suppose your V, this is now y-axis 0, this is now your x-axis, and here we take the current I. Then this current is just like to have like this one. This is the graph that shows, or more better to have it like this one, like this. So this graph does not pass through the origin, and you can see that here this voltage is equal to 0. Voltage equal to 0 means that current remains so much. The current is constant. The strength of the current does not diminish when the voltage source is removed from the superconductor. So much current exists for a long time, and you can see that this curve is no more a straight line and it does not pass through the origin. So as this value of V is increased, then this I will increase, but here we can see that if we take it like this one, the value of voltage is decreased, so this I will also decrease, and here the voltage is equal to 0, but current will remain so much. So these are called the persistent currents. Persistent current means the current which flows for a very long time without any change in it. So this is what the key points of the Ohm's law. So we have to remember that this is asked in this is very useful for the students preparing for the board exam and the NEET exam or other competitive exams belonging to the science stream. Thank you.